All right, on the constructions, there's a portion where you're trying to discover whether or not some of these quadrilaterals, special quadrilaterals, can be inscribed versus circumscribed. Drawing a circle on the inside, drawing a circle around the outside. You can't do it for every single quadrilateral like you can for every single triangle. Some of them you can, some of you can't. Okay, so the review is this process of discovery to see which ones you can. We're going to do a kite here. So I'll start with the kites. One of the methods to make a kite has to do with the fact that its diagonals are perpendicular to each other. So I'm going to start with, let's say, a perpendicular bisector two-tailed fish construction. This would be one way to make a kite. Now, if I connect this top point to that point and the top point here, I don't want to do the same thing down here because then it's going to turn it into a rhombus. And I want it to actually be a kite and not a rhombus. I'm going to go ahead and draw in this other diagonal. So if I connect these two top points, this could be the top side of my kite. I don't want to use this point. I just pick one maybe a little bit further down. And then I can ensure that not all of my sides are congruent to each other. Alright, so then I have myself a perfect kite. And now I want to try to see if I can inscribe it. Okay, so if you think back in terms of triangles, the inscribed circle came from which? An angle bisector. Now, one of these diagonals is already an angle bisector. It bisects the two vertex angles. We don't have the angle bisector for this one, so that's the next thing that we're going to get is just find the angle bisector of one of these obtuse angles here and see what the point of concurrency is and see if we can use that to draw ourselves an inscribed circle. So the construction for bisecting an angle is the sad dead cyclops. So I'll draw myself an arc that intersects both sides of this angle. Since this is an obtuse angle, I'm going to stretch out the compass a little bit more to find the dead guy's eye. And now I'm going to connect this point of intersection back to its vertex. Okay, so where this horizontal diagonal intersects the other angle bisector, this point intersection, if I can inscribe it, that means that this point here is the incenter of the entire kite. And an incenter is supposed to be equidistant to the sides. And whenever I measure a distance from a point to a side or a point to a line, I have to measure it perpendicularly. So the radius of this is not going to be the distance from this point to that vertex. It has to be perpendicular to a side. And it doesn't matter which side because it's supposed to be the same distance to every single one of them. So I'm going to just go ahead and make it perpendicular to this piece here. In order to do that, I'm going to extend out this side because whenever I make my my construction, it's probably going to go outside of the kite. So I'll extend out this side. I'm going to pick a compass setting that's bigger than the distance from that in-center to this side. And now make myself an arc that's going to intersect this bottom piece twice. Like so. So here's my sad face, which kind of looks like a happy face at this point. I'm going to put these 2 points of intersection here. And then I should be able to use the same exact compass setting to get the dead guy's eye down here at the bottom. And then from this point of intersection, this time maybe I should make this another color. I'm going to connect that to the in-center. And does that look like it makes a right angle right there? I can confirm that by putting a piece of paper right there in the corner. It definitely looks good. So this should be the radius. I'm going to use that radius with a compass setting to see if this intersects all of our sides. Ta-da! We sure can't. The bell just rang.